everybody, my name is Christian and welcome back to our series of videos about the most important parts of each lesson. Today, as you can see, I'm wearing my Colombia jersey because today is Colombia's match against Japan in the afternoon. So you're going to see maybe 6 or 7 videos because that's why I'm recording it today with me wearing this beautiful jersey. So I hope that tomorrow I will have a beautiful, lovely smile because, you know, fuerza Colombia. Okay, let's get it on. So today's lesson is ATP, energy obtention. There are only 2 ways, aerobic and anaerobic ways of obtaining ATP. In some bacteria, you have something that is a mix between aerobic and anaerobic. But in general way, we can say that we only have 2 kinds of respiration, 2 kinds of obtaining, breaking down sugar to obtain ATP, which is aerobic and anaerobic. Aerobic uses oxygen, anaerobic doesn't use oxygen. Pretty simple, pretty straightforward. Of course, since combustion is one of the most, if not the most energetic reactions in nature, apart of course of nuclear reactions, but plasma and combustion are the normal common reactions that extract the most amount of energy. Therefore, you can suppose, elicit from context that aerobic respiration produces more ATP than anaerobic respiration. Today we're going to focus on only aerobic respiration. And we're going to focus only on the important parts. Aerobic respiration in superior animals is divided in 3 steps. Only 3. In mammals and in animals, it's only 3. In eukaryotic cells, it's divided in 3 parts. Ready? Go. The first one is glycolysis. Glycolysis comes from 2 roots. Glycos, sugar, lysis, breaking down. Glycolysis literally translates to breaking down sugar. Easy, right? Second step, Krebs cycle. Why? Because the name of the person who described this cycle was Krebs. Now, this normally is regarded as the most energetic part of the respiration. Well, it's not. It's the most famous, probably because of the series of reactions that it contains. I have a diagram on my back here that is what you normally find. You normally find a circular diagram of Krebs cycle. But probably it's because it's the most kind of complex in a way to remember. So, just for you to know, for you to remember, we have acetyl coenzyme A, citric acid, isocitrate, alpha-ketoglutamate, succinyl coenzyme A, succinate, fumarate, and then we get together with puric acid, with acetyl coenzyme A, and start over again twice. I know that these names are kind of complex. That's why we have something called mnemonics. What is mnemonics? The use of different words, a series of words or sentences that drives our memory, that gets our memory into this. I have a series for this. I have several series for several processes in biochemistry because my memory is horrible. So this method helps me remember way better. Ready? Normally I say, can I keep selling sandwiches for profit, officer? Again, can I keep selling sandwiches for profit, officer? Can I keep selling sandwiches for profit, officer? Easy. Third step, the electron chain transport. This is the most ignored part of the process, but it's actually the one that provides the most amount of ATP. We're going to see in the next video how much ATP we produce in each one of the steps, but just to tell you, just simply telling you, the first one, glycolysis, produces 4 net 4 total, 2 net. I mean, it produces 4, sorry, but uses 2. ATP produces simply 2 ATPs. But the importance of the Krebs cycle is not the amount of energy it produces, because that's marginal. It's just, like, okay, I'm going to do something important, and also I give you ATP. Because the important part of the Krebs cycle is not, and I repeat, it is not the production of ATP. It is the production of NADH, NAD, FADH, FAD. Without this, no energy, because those are receptors. Those are the ones that take the hydrogen, carry it to the mitochondria, from the mitochondria matrix to the crystal, and make these electrons jump. And the electron jumping, and I have it here, is what actually provides ATP. We're going to get into this diagram a little bit later, because this is a little bit more important than all the other. So just for you to know, this diagram, I'm just going to move the camera a little bit here. So this diagram here is exactly what we're talking about. We have complex 1, complex 2, complex 3, complex 4, complex 5, which is actually not a complex, but we call it complex 5, so this is ATP synthesis. We're going to go there. So remember, glycolysis, breaking down sugar, Krebs cycle, simply circulating this modified molecule of sugar into taking something away, and that way producing NADH and FADH, and electron transport change, which is actually the one that receives the hydrogen that were left in this part of the reaction to convert them in ATP here. My friends, that's it for today. Colombia.